Fundamentals of Statistics. This is chapter 4. In this chapter, we're going to understand the definition of statistics, also understand the definition of data and the type of data, and the definition and the difference between population and sample. So let's start defining statistics. And a statistic is the science that deals with the collection, tabulation, analysis, interpretation, and presentation of quantitative data. In the beginning, when you are collecting data, the data might not mean much to you. But once you start tabulating and analyzing and interpreting this data, it will become a powerful tool for you to predict the behavior of a process, system, etc. Now, statistic has two phases. The first one is a descriptive or deductive phase, and the second one is the inferential or inductive phase. The first phase describes and analyzes a subject or a group, and you can figure out by its name, descriptive. Now, the second one, the inductive statistics, what it does is determine from a limited amount of data, which what we call the sample, an important conclusion about a much larger amount of data, and this is what we call the population. So the inductive statistics help you to understand what will happen with that specific population based on the analysis of a sample size. Now, to understand statistics, you need to understand everything about data, okay? And because this is the first step, is collecting the data. Now, the data may be collected by direct observation or indirectly, and this could be through written or verbal questions. There are different techniques that you can use to collect data, and we're going to see this in this semester. But the way that you collect data is based on the results that you want to get. So based on the results that you want to get, you go back and understand the type of data that you need to collect first. So the data are collected for quality purposes. And once again, this could by direct observation or indirect observation. Now, the data is classified as either variables or attributes. So attributes are those quality characteristics that are classified as either conforming or not conforming to a specifications. This is what we call discrete data. These are data values that can only be integers. It's also what we call counted data or attribute data. In some of examples of this type of data is decisions such as go or no-go gauge, how many phone calls in a call center, how many car has passed this intersection between 12 and 3 p.m., etc. So these are the attribute data. Now the other group or the other classifications are variables, and these are quality characteristics that are measurable. These are what we call continuous data. The data values can be any real number, and these are measured data. For example, the weight measured in grams, your height, the gallons, meters. These are different type of variables. Another concept that is very important when we are working with statistics is the precision and accuracy. So precision is a measurement and is determined by how reproducible this measurement value is. So it means that if you can reproduce the same value, the same measurement value, you can say that your data is precise. Accuracy is a measurement that is determined by how close a measured value is to its true value. So if you have a target value and you have some data, accuracy, you can say that your data is accurate because it's very close to its true value, which is the target value. Another concept that you need to understand is about significant figures. Insignificant figures is what we call measured numbers. So when you measure something, that is always a room for a little bit of error, and you have to understand this. For example, if you ask how tall are you, a person can say, well, I'm 5'9", but in reality this person is 5'9.1" inches. So this is what we call, there's a room for a little bit of error. Also, you have counted numbers and defined numbers. Okay, for example, we know that 12 inches is equal to 1 feet. Or you can say, well, I have 6 people in my family. It has no decimal values. Now, when we describe data, and this is part of the descriptive statistics, we use 3 different methods. And these are the frequency distribution, the measures of central tendency, and the measure of dispersion. If we want a graphical way to do it, we will use the frequency distribution, which it is a summary of how data points, which are observations, occur within each subdivision of those observed values or group of observed values. The analytical techniques are either the measure of central tendency or the measure of dispersion. And you can also use them in a graphical way as well, because if you have a graphical or a frequency distribution, you can locate the different measures of central tendency of the dispersion within that distribution. So when you describe data, you can use either the graphical techniques, you can use the analytical techniques, or you can use both the graphical and the analytical technique. The frequency distribution, you can have ungrouped data or grouped data. The ungrouped data comprise a listing of observed values, whereas grouped data represents a lumping together of the observed value. So it means that you got ungrouped data is just a set of data set, where the grouped data it might represent or might have a different meaning or have more meaning to you. Now, this data can be discrete or could be continuous. Discrete as an attribute or continuous as a variables. Now, there are different type of frequency distributions, and this the first one is the categorical frequency distribution, and these can be used for data that can be placed in specific categories, such as nominal or ordinal level of data. For example, you could say that political affiliation, because you have either, like in United States, you have Democrats, you have Republicans, and you have independents. So because you have either one of those classifications, these are what we call the categorical frequency distributions. Religious affiliation, blood type, and it's because you have defined set of categories for this classification. So when you can classify the data in different categories, this is what we call the categorical frequency distribution. And for example, this is the blood type frequency distribution, in which you have class A, B, O, or AB, and you have the frequency. This is for a different for a set of sample, and then you have the percent. For the ungrouped frequency distributions, these are the ones that can be used for data that can be enumerated, and when the range of values in this data set is not large. Some examples of this type of distributions are the number of miles your instruction have to travel from home to campus, or the number of girls in a 4-child family. So these type of data can be enumerated. For example, number of miles traveled. You can have classes for 5, 10 miles, 15 miles, and then you have the frequency for them. The grouped frequency distribution, these are the ones that can be used when the range of values in the dataset is very large, and the data must be grouped into classes that are more than 1 unit in width. Example of this is the life of a boat batteries in hours. And this is for example, so you have the class limit. This is when, remember building the histogram, that we have the number of classes, and then you understand the class boundaries, and then you find the frequency and the cumulative frequency. And this is just an example of a frequency distribution. So the frequency distributions are represented in a graphical form when the greater visual clarity is desired. And there are different ways to present the frequency distribution. You can have a frequency, a histogram, and this consists of a set of rectangles that represent the frequency in each category, and it represents graphically the frequency of observed values. Another graphical representation is the relative frequency distribution, and it means the proportion or fraction of the total. So the relative frequency is calculated by dividing the frequency of each data value by the total, which is the sum of the frequency. You also have the cumulative frequency, and this is calculated by adding the frequency of each data value to the sum of the frequencies for the previous data value. Another concept that is very important to understand in this field is population and sample. Population is a set of all items that possess a characteristic of interest. And then you have the sample, which is a subset of a population. Now, sometimes you could work with a population, but most of the time you're going to be working with a sample, because working with a population is, one, either too expensive to do it, or B, too time consuming, or C, because it's a large population, or C, is very costly. So what you do is you work with a sample, and it has to be random sample that could represent all possible characteristics of that population. So you study that, you analyze, you collect data, and then you can predict the behavior of that population based on that specific sample size. Now, when you use population, you use parameters because these describe a population. When you use sample, you use statistic because these are characteristics of a sample, and they're used to make inferences of the population parameters that are typical unknown, and these are called an estimator. So this lecture helps us to understand the definition of statistics, the different phases of statistics, the different methods that we can use to describe data, and the definition of population and sample.